Hi, Nikhil. I think you're mute.
Okay, can you hear me now?
Yep.
Okay, sorry, I was muted. I didn't realize.
No issues.
So I had added MCI to the agenda. I'm not sure if there's anything else.
Yeah, that's the only agenda item for today, and we were waiting for update on that.
Okay, sure. So yeah, in terms of where we are, I'll start with the Kubernetes CLI that we had. So we put it out for customers to try it out. There are a few people who tried it out. I had also linked to an issue in the meeting notes that has more feedback from customers, the issues they're running into or the status where they are. There are a few customers who are trying it out. There are a few issues we've discovered that we are working on fixing, but it's great to see good feedback and people saying it works. So, that's where we are for the CLI. I'm not sure if there are any users here who'd like to add something more or give feedback.
Are there any Kubernetes users on the call?
Yeah, so that's where we are for CLI. As a next step, we are working on an API, which is still a very, very early stage. It's work in progress, but I wanted to share it with the community to get some early feedback. I have linked to the PR in the meeting notes. So at a high level, I can explain the API. We've come up with I've come up with two API resources. One is called what we're calling multi-cluster ingress, and one we are calling multi-cluster service. And so this is where the model is a bit different from the CLI, and I'll compare the two as I go, assuming like people know the CLI model. In the CLI model, you give an ingress spec, and the CLI syncs that ingress to all the clusters, and that's how you get multi-cluster ingress. With this API, there's a multi-cluster ingress, but that is not synced to target clusters. There's a multi-cluster service that is synced to all the clusters, and that's the advantage of this, that we don't have to force users to have to create service in all the clusters. That is done automatically using multi-cluster service. In CLI, it was on the users to have to create a service in all the clusters, ensure it has the same node port, and then ingress would be taken care of by the CLI. So the advantage here is you don't have to do anything in the clusters. You have deployments, and then you create multi-cluster service that is synced to all the clusters, and you create multi-cluster ingress that then configures Google Cloud Load Balancer to give you this multi-cluster load balancing. And so we have cluster selector support as well. In CLI, it was all clusters. You'll give a list of kubeconfig, and it used to use all of those clusters. Here, you can have cluster selection. So multi-cluster service, if you look at the API, it has a concept of destination clusters. And so which is based on label selection. So it's flexible. You can select a list of clusters based on that label selector, and your service would be synced to those target clusters. And by keeping the cluster selection on service, the advantage is that you can have different paths on the same multi-cluster ingress pointing to different clusters. For example, you can have /foo in clusters A and B, and /bar in clusters B and C, and you can have like those cluster selectors are independent and can select different clusters for different paths. So that's another advantage you get here. Yeah, so that is most of it. The API, if you look at it, multi-cluster ingress looks very similar to single cluster ingress. It has very similar config, just that in path, when it points to a service, in multi-cluster ingress, it points to multi-cluster service instead of pointing to a single cluster service as it does in single cluster ingress. So that's the only API difference in ingress. In service, like I said, we've added this cluster selector. So that's the difference in service. So these are the two main things. Are there any other questions? Or I can present PR that I have for API if that helps.
No, before that,
I've added the link to the PR in the meeting notes, and I would love any review or comments on it. So anyone who's interested would be great if you can take a look. and review it and add your thoughts.
Yeah, I had a question mainly because I'm not, or in fact, many of the folks over here might not be updated about that.
Comment.
Hello, am I audible?
Yes, I can hear you.
Do you want to present it here?
Okay, it seems, Nikhil, are you able to hear us?
The PR, I
Yeah.
can.
Maybe
I
like
think they are
call
not able
somebody.
to hear us now.
Versus
Nikhil, I think Irfan is trying to ask a question, but it sounds like you can't hear him. Can you hear me?
Let's see. You can see my screen. Can you guys see my screen?
Hello. Yes, we can.
Oh, okay. Sorry, I wasn't able to hear you guys.
Yeah,
Did I say
so
anything before? Sorry.
yes, we were trying to say something.
Sorry, I just realized.
Awesome.
I was just traveling.
Okay, so what I was asking is mainly because, including me, most of the folks over here are not up to speed on what developments that have happened on the multi-cluster ingress. I remember the last time you had an update, you also had plans of having an active controller associated with it, or some reconciliation, active
Yeah.
reconciliation, which might be there. So is that implemented? Like, does that exist now?
No, so this is a first draft at the API. So we are looking for review on the API and still working on this. But yes, we would need a controller with this API for it to be.
Okay. So that's like you seem to be moving in that direction. That's what that means.
Yeah. Yeah. Like with this API, we would need a controller. Yes.
And how and where? I mean, if it's not too early, do you intend to implement and then probably at runtime run that controller? MCI is a tool which is like a command line tool, right? And
Yeah.
if you need an active controller, then where do you plan or intend to run it, or say release, or whatever might be the life cycle of it?
Yeah, that's a great point. Like when we implement a controller, we'll need a way for it to run it. That's still an open question. Like we had set up with Federation that you can run it on. You can choose a host cluster and run it there, or people were running it on like their laptops. You try it out. So any of those models would work with the controller as well. You can use a host cluster or run it in, or if you want HA, run it on multiple cluster in different regions.
Okay, that was mainly my question. Like I wanted to just understand where exactly you guys are heading.
Yeah, so that's the like standard any multi-cluster controller hosting architecture.
Okay.
And Nikhil, superficially, this looks very similar to the Federation v2 multi-cluster service and multi-cluster ingress.
Yeah, so I can clearly update about that also if you guys want to know.
Yeah, my question was basically going to be, does it make sense to have two completely separate efforts that seem to have the same goal? Or if the goal is different, can we kind of clarify? I'm worried about people getting confused as to which one to use and why, and if they're basically the same thing, or should we collaborate and make the APIs consistent at least?
Yeah, we should definitely collaborate. This is a very early version of like what we thought would work. We should definitely see how we can merge them together and make it work. This is still like very early. Yes.
Sorry, Irfan, carry on.
Yeah, so I just wanted to extend what you are saying. So we have similar APIs relevant to networking. So we have a service DNS, we have a multi-cluster DNS, and an ingress API in Federation v2 right now implemented and with controllers. So it might make sense for you to maybe at least have a look at that. And as Quinton mentioned, maybe not necessarily as part of this meeting, but somewhere offline we can sync and figure out where we differ or if it makes sense to collaborate together.
Sure. Yeah. And since you are very familiar with that API, it would be great if you can take a look here as well, and we can figure out like does it still look very similar, and like those are simple cosmetic changes, or does it look like fundamentally very different? I doubt that, but it would be great. Like if you feel it's very different, add a comment, and yes, we should definitely discuss.
Sure,
Nick,
I'll do that.
sorry, carry on, Irfan.
I said, yeah, sure, I'll do that. I had a superficial look at the PR that you have posted here.
Yeah.
So the mechanism that we are following to implement is quite different from what you are trying to do right now. I mean, at least having a look at the API is what I can say that.
Oh, so can you expand on like what's different?
So how we do, uh, setting aside the API or the fields in that and all, the mechanism that we follow in Federation V2 is that a federated resource is created specifying the intent user wants. So for example, for ingress, what user wants is to, so a simple mechanism of propagating ingresses would be that whatever ingress is created in federation control plane, same with same specification, it is replicated in each of the clusters. The additional point is that the ingress API will get, or the ingress object will get some IPs associated with it or some rules associated with it per cluster. So the user can create the intent of collecting all these resources and then programming some external DNS server or some external entity with this collected information. So that's how we are trying to do it. It's very similar for services also. And services, in fact, are very similar to what they were in Federation V1. So
Yeah.
a user creates a service and the services are propagated, and then service information, some information in services in each of the clusters, which is the IP against the DNS name, which is updated, which is collected in Federation control plane, and the Federation control plane hands over this responsibility to an external entity to update the DNS entries in some global DNS server. So that is how we are trying to do it in Federation V2.
Yeah, so in this case, we have similar, we are aggregating over services instead of like other ingresses or having like IPs in each cluster. Users create these services and ingress paths point to these services. And then multi-cluster ingress only gets a single IP. Like there's no DNS routing here. This is the single virtual IP. I think that seems to be the
Correct. So that ingress for us is also at that. We have been thinking about trying to figure out a solution where, for example, you program an ingress in a single cluster using paths, right, to differentiate the different services or different entities which might be served from that ingress. To map it somehow to some similar DNS-based mechanism. But we haven't been successful so far. So it's a simple collection of whatever, as you mentioned, a single IP right now, and then updating it in some global location.
Yeah. So you said you also have like a working controller. Like, does it work with Google Cloud Load Balancer, or like, with what
So
integration does it have?
I don't have the first-hand information about this. She is the person who implemented, and I don't think he's on the call right now. But what he has tried out his implementation is with Core DNS as an external server, and with some OpenStack load balancers is what I remember he tried out his implementations. I don't think he has tried it out with Google load balancers.
Okay. Yeah, because that's one of the advantages with Google Cloud Load Balancer. You get the single unicast IP. Sorry, unicast IP.
Yeah, I understand. So also there is one more hurdle, which is like individual clouds provide load balancers with different capabilities. So
Yes.
it's difficult to have a unified this thing.
Yeah.
Having said that, I am sure that we can try to come up with some common solution across some platforms at least, if
Yeah.
not all.
Yeah. Yeah, that's why you'll see in our model, we have this in status here, you'll see there's only just virtual IP. There's no DNS.
Mhm.
Because like, yes, this is specific to GCLB. like you said. We can add other fields here, and it can
Yeah,
be an option.
I'll have a more. I mean, in fact, I'll ask Shashi also to have an in-depth look at what you guys are updating, and then we can maybe sync offline. Some other
Yeah,
time.
it would be great if you can add comments so
Yeah.
we can have this,
And next week, I guess we might be meeting at the KubeCon, right? So we can elaborate and talk in detail over there also.
yeah, so I won't be there. Yeah, so we can discuss that offline when we
Sure,
discuss.
sure.
Discuss when to discuss.
Yeah.
Yeah, Irfan, I was going to suggest, I think it would be super useful because as far as I understand, the delta between what is currently in Federation v2 and what this would provide in the future, namely Google Cloud Load Balancer integration, is relatively small. I mean, modulo all of the cross-cloud complications, you know, if you have clusters in different cloud providers and they can't all sit behind a Google Cloud Load Balancer, I think it would be useful for us to just build that anyway. I think we had the implementation in V1 already, so I presume it's a reasonably small step to port that to V2. If that was the case, Nikhil, would it still make sense to pursue a completely separate one, or would it? Yeah, I'm just curious why you had a completely separate starting point rather than starting with what's already in Federation V1 and V2.
Yeah, like this is more of an exploratory or brainstorming. Like we just wanted to come up with something that would work and see and get feedback on that. So like this is the model we came up with. We wanted to see if like what's the community feedback on this as well. Like like the model is a bit different than, like I said, what we were doing in Federation V1. We don't sync multi-cluster ingress here. We sync multi-cluster services. And those are created based on cluster selection. So
okay, so you removed the in-cluster ingress controller completely. Makes sense.
yeah, yes.
But
So this is just a model. Sorry, go ahead.
no, I was going to say the end result is pretty much the same in the sense that the external load balancer, the Google Cloud Load Balancer in this case, gets configured to send the traffic directly to the pods in the service. It's just where that programming happens, whether it happens in the multi-cluster stroke federation control plane, or whether it happens is done by the ingress controllers in the clusters.
Yes. So at a high level, yes, that is correct. One distinct or primary difference here is users don't have to create services in all the clusters. So that's a requirement we had in CLI and in Federation V1, that users have to ensure there's a service exists with the same node port in all the clusters. And like that's the feedback we've got, which is obviously a pain for them. And so this API model specifically alleviates that. Like that's the primary difference.
Oh, okay. So it automatically creates the services based on the ingress definition, rather than having the two as no. But you have a multi-cluster service.
Yeah. So it automatically creates the services in target clusters based on multi-cluster service, and then multi-cluster ingress points to multi-cluster service in its path.
Okay.
So users create multi-cluster service at this multi-cluster level, and then the controller syncs those services in target clusters. So users don't have to create services in target clusters themselves.
But that's exactly what a V1 federated service did, and also what a V2 federated service does, correct?
Yeah. So in V1 service, or V1 federation, sorry, we did have this service concept, which did this global or cross-cluster service discovery as well. So yes, it did sync services and also route DNS paths and other stuff. If you just wanted to use multi-cluster ingress without that cross-cluster service discovery, without having to expose your service outside to other clusters and do DNS routing as well, in that case, users had to create those services themselves and ensure they have the same workload. And even in service, when in V1 federation, when users wanted service to be created in all clusters, there was this problem that they would run into for node port, that the same node port could be already taken by someone else. So in this case, I would point out, so GCLB has this new feature called network endpoint groups. So this uses that, which does direct load balancing to pods. So you don't need node ports now. So this is based on like that new one. With this API, we can take advantage of that new one.
Okay. I actually thought V1, I mean, if you specified a load balanced service, then you got a load balancer and DNS and all of that other stuff. But if you just didn't specify that, you didn't get all of the other stuff. And if you didn't specify a node port, you got the automatically allocated node port. So in which case, I think it is equivalent to a multi-cluster service, if I'm not mistaken.
So there was the DNS routing, and yes, there was automatic node port, but we did customers run into a lot of issues where the node port was already taken. And like we've discussed these design questions where what does the controller do? Then it restarts. Or if you add a new cluster, and like first you had 3 clusters and the federation service controller was able to find a node port that exists in all 3 clusters. But then now you add a new cluster and the node port doesn't exist there. So then it'll just fail. So we had like some of those issues, which were because of having to have a unique node port, which that requirement is gone now. So we can have
I don't remember that far back. I wasn't aware that there was such a requirement to have a unique node port.
Unique and same consistent node port in all the clusters. Because GCLB had the same health check, you could specify only one port for all your backends. So
that was because of a GCLB limitation. Okay, which is now gone. Okay, now I understand.
Yes. Yeah, so I'm curious, even in Federation V2, when you create a Federation service, does it do all the DNS routing, cross-cluster service discovery as it did in Federation V1?
Yeah, for service, most of the loop is complete and it can do exactly the way it did in Federation V1. The only piece that we have integrated externally is instead of using the DNS libraries, which were inherently part of Edition V1, we offload that to external DNS. So there is a project in Incubator, I think, Kubernetes Incubator, which is called external DNS, which can take information from the Federation API and updates the DNS records. And it has many DNS servers, and it can do the same thing for many DNS servers, which include all the major clouds.
And do we have this functionality where I can create the service just to sync it in multiple clusters without doing the cross-cluster services?
Exactly. So that's the basics of that's the basic ability, and that can be done for any type, not just service. The basic sync can happen for any KTS type, and the cross-cluster service discovery is built as a higher layer. It's built based on the sync mechanism.
Nice.
Does the service have to be externalized though? Through public IP?
If the users have to reach those services, they have to be externalized. Means external users have to reach those services. Yes.
Yeah, if you just need cross-cluster service discovery, then you don't need to.
Yes.
Nice. Because that was another requirement in Federation V1, which was on design.
Yeah, so if a user in cluster 1 needs to reach a service in cluster 2, the cluster 2 services will have to have an external endpoint, right? So that is still there.
Okay.
But presumably, if you put ingress on top of that they can use the ingress instead of the external.
So
service.
Exactly, that is what I was looking at right now. So the Federation V2.
Sorry, I didn't mean to interrupt you, Christian.
No, sorry, Irfan was talking.
Yeah, I was saying, so I might be slightly wrong on this, but I was just having a look at the V2 API for multi-cluster ingress. So what it does is it basically just collects all the ingress IPs for all the clusters. So you create a service in each cluster, you have this service, you have this cross-cluster service discovery mechanism, and then additionally you create a multi-cluster. We call it ingress DNS. Multi-cluster ingress DNS is the name of the API. So which says the intent is for a given ingress name, which will be common in all of the clusters, just collect the ingress endpoints. So each cluster will have ingress IP or the external IP through which user can reach this ingress. So DNS records are created for that external IP also, in case you don't want to have external endpoints or load balancer type services in the clusters. So it seems very similar to what you are trying to achieve.
Okay, I was trying to parse all that. I'm just wondering, does that mean you support the use case where you can externalize the ingress IP, but keep the service IPs not externalized?
Yes, local cluster IP kind of a thing. That seems to me the case.
Cluster IP.
So
I don't think cluster IP would work cross services.
So
sorry, cross cluster.
Yeah, so that's what I was trying to say. So you can have a service defined as a cluster IP only service, which does not have an external load balancer type. Then you can create an ingress by its side, and the ingress rule can be such that it will redirect the traffic to this particular service. And the ingress can have an external IP, right?
Yeah, as long as the service is reachable using its cluster IP from the load balancer.
Yes, ingress load balancer.
Which is not guaranteed, right?
Yeah.
Cluster IP is local to the nodes running in the cluster.
Yeah, like only kubedns would know about, or the kube proxy IP tables configured in the cluster would know about that cluster IP.
So you're right. So I guess the point I'm trying to get at is one of the feedback we got from our users was that they have internal services in multiple clusters that they would like to program through ingress, and how would they be able to do that? And this is why we're trying to be a little bit prescriptive, not get into the business of cluster IPs or allocating DNS, and certainly not externalizing all the target services that have to be part of the ingress. So maybe that requires a bit more documentation around the types, but that's what you have to read between the lines.
Yeah, I sort of get it. Would it make sense, Nikhil, at least I mean, we can set some time aside. As I said, I did not implement any of this, so I might be mistaken on something, and I would not have the very deep understanding of each of these APIs which are implemented in traditional V2. But Shashi has that, so I'll ensure that he attends that next call or discussion whenever we set a time aside.
Sure, and just like you, me, and Shashi can have a meeting offline.
Exactly, that's what I was trying to indicate.
Yeah, and then we can report back to the
sure.
SIG.
In probably the next multi-cluster meeting.
That sounds good.
Well, I'm certainly more interested in learning more about service DNS. I'm going to spend some of my own time catching up on that, but we can keep this on the bi-weekly agenda as well.
Sure. I'll add an item for next meeting.
Yeah, I think it'd be really useful if we could unify these in such a way that we have at least a single API, even if we have different implementations of that API, a single API that addresses the use cases that you mentioned, Christian, which I think are perfectly reasonable. You know, don't use cluster IPs, don't use external DNS, route ingress directly to the pods in the cluster, which is essentially my understanding of your requirement. And it doesn't sound like the delta between that and what we have is very large at all.
Okay, cool.
Okay.
We're losing the room. I think we're towards the end anyway.
Yeah, I think we can, I mean, I don't think there is any other item to discuss. I did not hear anybody else shout out to talk about anything else, then if that's the case, then we can close the meeting now.
Cool. See you, some of you, hopefully in Seattle next week.
Yep. Bye-bye.